Okay. So we will be beginning with the isotopes. See, you might have studied in your 10th standard like periodic table is there, right, in which we classify all the elements present in on the earth. See, so whatever elements we have come to know, we have discovered, we classify it in a periodic table, and there is a concept of atomic number and mass number. There is a concept of atomic number and mass number. See, I am not dictating any notes. You can prepare a running notes, and whatever I am speaking in the class, you will be getting a PDF handout for that. So you will be leaving nothing, and you can prepare running notes, because you will be able to revise, or you will be able to recall when you will go home and you will open your notebook. You will be able to recall what was discussed in the class, right? So there is a concept of atomic number and mass number. See, this is a nucleus, and electrons are revolving around it, right? And there is a neutron and proton inside the nuclei of the atom. So this is the basic representation of an atom, and neutrons, protons and electrons, in which electron is a negatively charged, proton is a positively charged, and neutron is neutral, no charge on that, right? So atomic number is nothing but the number of protons, right? And mass number is nothing but number of protons plus number of neutrons. Okay, we classify the elements on the basis of atomic number. Now the isotopes are those elements which have same atomic number but different mass number, which have same atomic number and different mass number. What do we mean by that? We can take an example of hydrogen. So we are aware of hydrogen atom, right? There are 3 isotopes. One is protium, one is deuterium, and one is tritium. So hydrogen has atomic number 1, right? So we are writing atomic number at this place. So hydrogen has atomic number 1, and there are 3 mass number of it, like protium. So we can write like this also: 1H1, 1H2 and 1H3. So these are atomic number 1, and these are mass number, different mass number 1, 2 and 3. So protium, deuterium and tritium. You can write like this also: 1P1, 1D2 or 1T3. So any of which will do. So you can write by this. So this is atomic number and this is mass number. What do we mean by this? See, when this is hydrogen atom, and these are the 3 isotopes. Right? When this protium reacts with oxygen, it produces light water. This is light water. When deuterium reacts with oxygen, it gives heavy water. And tritium does not react with oxygen because it is a radioactive element. It is a radioactive element. It emits alpha rays, gamma rays that you might have studied earlier. So it is a radioactive element, right? We will discuss this light water and heavy water when we will discuss nuclear reactors in which there are moderators and coolants. So we will discuss these light water and heavy water there and the application of it. Similarly, as we have three isotopes of hydrogen, we have many isotopes of uranium. Many isotopes of uranium. Its atomic number is 92 and it has different mass number. So isotopes are nothing but same atomic number but different mass number. So we have many isotopes in which three are important. So we will discuss three isotopes of uranium. Uranium 233, uranium 235 and uranium 238. See, we don't have to write 92 every time because we know the atomic number for uranium is 92, so we can write only mass number, right? Now, see, this uranium 233 and uranium 235 are fissile in nature, and uranium 238 is fertile in nature. What do we mean by this? Uranium 233 and 235 are fissile in nature, where uranium 238 is fertile in nature. This is a neutron, right? This is a neutron. When you might have studied bombardment of particles in labs, bombardment of proton, bombardment of neutron when we conduct experiments, right? So this is bombardment of neutron on uranium 233. Bombardment of neutron on uranium 233. What will happen? This uranium will break down into some XY element, lighter element than uranium, So it will split into two different elements. We are not concerned about that element, which element is there. But when there is a bombardment of neutron on uranium 233, it splits into two lighter elements, plus neutron plus heat. Heat will be generated in this reaction. This heat will be used to run a turbine. This heat will be used to run a turbine, and hence we can have electricity. This is a peaceful use of nuclear energy. Peaceful use of nuclear energy, right? We are generating electricity from it. You will run a turbine through the steam that will be produced because of this heat, right? So heat will be manifested in steam and it will be used to run turbine, and turbine will produce electricity. This is a peaceful use or civil use of nuclear energy. If you use this heat, for explosion, this is nuclear weapon. Mass killing, like we saw in Hiroshima and Nagasaki. So there are two uses of nuclear energy or nuclear reactor, the production of heat. If it can be used for explosion also, it can be used for generating electricity also, right? So this is the civil use and this is the weaponization, right? Military use. So uranium 233 or uranium 235, both, because both are fissile in nature, so it undergoes fission. What do you mean by fission? It breaks down into two lighter elements. This is fission, okay? But we have seen uranium 238 is fertile in nature. Fertile. What do you mean by fertile in nature? When it is bombarded with neutron, it simply gets converted into a new element known as plutonium. Plutonium 239. And this plutonium, this plutonium will be fissile in nature. This plutonium will be fissile in nature, right? Now there is one more element, thorium. India has one of the largest reserve of thorium. When it is bombarded with neutron, it gets converted into uranium 233, and we have seen uranium 233 is also fissile, right? It will undergo fission. So uranium 238 is fertile, thorium 232 is fertile. When uranium 238 is bombarded with neutron, it gets converted into plutonium. When thorium 232 is bombarded with neutron, it gets converted into uranium 233. Fine. So I hope we are clear on this. There are 3 isotopes that we have to study of uranium: uranium 233, 35 and 38. 33 and 35 are fissile in nature, 38 is fertile in nature, right? Fissile means 33 and 35 will be break down into lighter elements and it will produce neutron and heat. See, when this neutron is why it is continuous chain reaction? Because this neutron will hit another atom of uranium 232 or 235, 233 or 235. What will happen? This is the reaction, simple. This is the one dimensional simple reaction, neutron bombardment with uranium 233. But there is not a single atom of uranium 232 or 233. There are multiple atoms of uranium 233 present in this reaction. So this extra neutron will hit again this uranium and it will undergo a chain reaction, right? So it will generate ample amount of energy, right? So this is only one part of the reaction. It has many such reactions, which is known as chain reaction. Fine. So are we clear with this? Isotopes. What are isotopes? What are fissile and fertile material, right? One more thing I want you to understand here is uranium 233. We have got uranium 233 from thorium 232, right? We bombarded neutron on thorium 232 and we got uranium 233 because thorium is fertile in nature and it gets converted into uranium 233. That means this uranium 233 is not found in nature, because we are getting uranium 233 from thorium, right? So this is not found in nature. So which two isotopes will be formed in nature? Uranium 235 and uranium 238. They are found in nature, whereas uranium 238 is fertile and this is fissile. I hope we are okay with this. Okay. Now, uranium enrichment. See, we have come to a conclusion that uranium 233 is not found in nature, uranium 235 is found in nature and uranium 238 is found in nature, right? Now, we have seen that uranium 238 is fertile, which will not go under fission, right? But uranium 235 will undergo a fission. So naturally occurring uranium will have these two isotopes combined. Whatever uranium we found in nature, that will be having these two isotopes combined. And uranium 238, the percentage of uranium 238 will be 99.3%. And the percentage of uranium 235 will only be 0.7%. Now, what will you use for nuclear reactor? Uranium 235? You have to use uranium 235 because you cannot use uranium 238 as it is fertile in nature. It will get converted into plutonium, but you need a fission. You need a fission to get heat, to run a turbine, to generate electricity, or to have a weapon use. So you need uranium 235, but you can see the percentage of uranium 235 is very less. So increasing the percentage, mark my word, increasing the percentage, not the quantity, increasing the percentage of uranium 235 in the naturally occurred uranium is known as uranium enrichment. You are increasing the percentage. So increasing the percentage of uranium 235, right? Increasing the percentage of uranium 235 is known as uranium enrichment. On the basis of uranium enrichment, there are two types of uranium: low enriched uranium and high enriched uranium. See, we have two isotopes, right? Uranium 238 and uranium 235. We are increasing the percentage of uranium to 235. If the percentage is increased up to 20%, it is low enriched uranium. Low enriched uranium. It will be having civil use. It will be used to generate electricity. Okay? And if you are increasing the percentage of uranium 235 beyond 20%, increasing beyond 20%, then it is high enriched uranium. And high enriched uranium, but if you are increasing the percentage beyond 90%, then it is a weapon grade uranium. Then it is a weapon grade uranium, right? So we have studied the naturally occurring uranium will have two isotopes, uranium 235 and uranium 238, because uranium 233 is not found in nature, we get it from thorium. Uranium, increasing the percentage of uranium 235 is uranium enrichment, right? The naturally occurring percentage is only 0.7%. If we are increasing up to 20%, then it is low enriched uranium. We will be having civil use of it. And if we are increasing it beyond 20%, it is high enriched uranium, and beyond 90% is a weapon grade uranium. I hope we are understanding this, right? Okay. So low enriched uranium and high enriched uranium. Now, see, we can not share high enriched uranium with any country. Why? The reason is it can be used for weapon and the nuclear arsenal. But we can share the low enriched uranium because it has civil purpose. It may be used to generate electricity. Fine. तो ये आ रहा है, समझ में आ रहा है थोड़ा बहुत? कुछ नया है, बिल्कुल नई न्यू टॉपिक है, आपने कहीं पढ़ा नहीं होगा अभी, पॉलिटी और इकोनॉमी में ये सब नहीं है, है ना? तो थोड़ा सा नया है, थोड़ा कोशिश करेंगे तो आ जाएगा समझ. जितना भी हमने पढ़ा, वट एवर वी हैव स्टडीड टिल नाउ, दैट देयर विल बी नो क्वेश्चन ऑन दिस इन द एग्जामिनेशन, बट इट विल बी helpful to understand the future topic which may be asked in the examination. But अभी जो हमने एक क्वेश्चन पढ़ा ना, low enriched uranium and high enriched uranium, 20% up to 20% is low enriched uranium, उसके बेस पे क्वेश्चन आया हुआ है प्रीलिम्स एग्जाम में, ठीक है? रिसेंट क्वेश्चन है 1920 का, वो मैंने उसमें वीडियो में डिस्कस किया है, वो अगर मिल जाएगी ना तो अपलोड हो जाएगी तो आप देख सकोगे वो क्वेश्चन. बाकी जो भी टॉपिक हम पढ़ेंगे, जैसे ही ये मॉड्यूल कंप्लीट होगा तो इस मॉड्यूल पे जितने भी प्रीलिम्स में क्वेश्चंस आए हैं, मेंस में क्वेश्चंस आए हैं, वी विल डिस्कस एवरीथिंग एंड वी विल डिस्कस सम एडिशनल क्वेश्चंस आल्सो, बिकॉज प्रीवियस ईयर क्वेश्चंस विल हेल्प यू टू अंडरस्टैंड व्हाट काइंड ऑफ क्वेश्चंस बीइंग आस्क्ड इन द एग्जामिनेशन, बट that question will not be repeated in the exam, so we have to practice more questions of the similar nature. So what we will do, whenever we will finish this module, we will be solving prelims questions, main questions, and some MCQs and subjective questions also. There were two questions asked in the mains examination on the basis of this topic. Okay, fine. So now we come to nuclear cooperation agreement. So why nuclear cooperation agreement? See, we have seen the impact of climate change. Now there is no debate whether climate change is real or not real, right? Now we know the climate change is happening and it is real. So the reason behind the things are, we cannot go for burning coal for a longer period of time, because you know the kind of impact it creates on environment, like production of greenhouse gases, etc. So it harms the environment. So we have to go for cleaner technology, right? You might have studied this 17 sustainable development goals. ये कुछ सुना है आपने इसके बारे में? 17 sustainable development goals by United Nations, sustainable development agenda to be achieved by 2030. So इसमें आप देखोगे, इसमें एक there is one goal for clean energy or clean source of energy. Clean energy or clean source of energy. So every country, be it a developing country or developed nation, it has to go for cleaner source of energy. So we cannot burn coal for longer period of time. We have to switch over some cleaner source of energy. So we are doing better in terms of solar energy, wind energy, but the efficiency is less. So we have to go for nuclear energy also. So we have to produce electricity from nuclear energy. But we don't have fuel. The uranium we have in India, uranium deposits, is less than 2%. Right? So less than 2% uranium we have in India. And we cannot generate so much electricity that is required, because the energy security, you might have heard about this word, and energy security, electricity for all, every time, electricity for everyone, every time. वैसा वाला नहीं, इलेक्शन आ गया तो इलेक्ट्रिसिटी आ गई, फिर इलेक्शन ख़त्म तो इलेक्ट्रिसिटी ख़त्म, वैसे. सो इलेक्ट्रिसिटी फॉर ऑल, एवरी टाइम, एवरी वन. सो इंक्लूजन, मतलब समझ में आ रहा है, इंक्लूसिव अप्रोच होना चाहिए इलेक्ट्रिसिटी के लिए. जैसे अभी दिल्ली में देख रहे हो आप, है ना, 24/7 इलेक्ट्रिसिटी है. इलेक्ट्रिसिटी नहीं है तो इन्वर्टर है. बट आप देखा होगा आपने रूरल एरियाज़ में इलेक्ट्रिसिटी आ गई तो मतलब बहुत अच्छी बात है ना, कभी कभार आ गई इलेक्ट्रिसिटी. तो we are, and electricity is much needed, right? Much needed resource. You need it for development and all. गर्म हो रहा है, ठीक है वहाँ पर, यहाँ पे गर्म. अच्छा, ठीक है. तो एनर्जी सिक्योरिटी, हाँ एक बात पूछ लो. आ रहा है कुछ, थोड़ा बहुत समझ में आ रहा है. क्या है, थोड़ा आपको भी ट्राई करना है कि इसको समझ सकें. ठीक है. सो वी हैव वेरी लेस फ्यूल अवेलेबल, तो वी नीड टेक्नोलॉजी ऑल्सो, वी नीड फ्यूल ऑल्सो, एंड टू हैव इलेक्ट्रिसिटी सिक्योरिटी और एनर्जी सिक्योरिटी, we don't have much fuel. So either we can drop the idea of nuclear energy. ठीक है, फ्यूल है नहीं हमारे पास तो हम छोड़ देते हैं न्यूक्लियर एनर्जी, जाने दो, नहीं चाहिए न्यूक्लियर एनर्जी, है ना. बट वी कैनॉट गो फॉर इट ऑल्सो. वी कैनॉट afford to lose nuclear energy because it is a cleaner source, right? So what we will do, we will import fuel from other countries, like right, we will do some agreements. So it is a part of international relations also. We will sign agreement with United States, with Russia, with France, and we have signed many agreements with US, UK, Russia, France, Kyrgyzstan, Kazakhstan, Uzbekistan, they mainly because these Central Asian countries have very high uranium deposits there, so we can import fuel from them, and we can import technology, that is nuclear reactor and the technology on which nuclear reactor works. We can import this technology from US or Russia or France, these kind of developed countries. These developed countries will share the nuclear technology, and the Central Asian countries or African countries, they can share the fuel required for nuclear energy, right? Fine. So we signed a number of agreements with many countries. These are known as nuclear cooperation agreement, but now you can understand that these nuclear technology or nuclear fuel, this can be used only for civil purposes, that is for generation of electricity. You cannot use this nuclear fuel or nuclear resources to generate your nuclear weapons, right? So we can understand this much, right? So in these agreements, why we need to go for nuclear cooperation agreements, that you can understand very well, that we need the technology as well as fuel, right? But when we sign some agreements, there are some obligations on us, something we have to do, and we will be getting something, right? So there are something which India will be getting from the outside countries, and there are some things which we have to promise that we will be doing this. So it is purely a give and take relation, right? So India was promised nuclear fuel, so we are in need of nuclear fuel, right? And nuclear reactors, so we will be getting 24 nuclear reactors. We will be getting 24 nuclear reactors, 12 from Russia, 6 from France, and 6 from US. Okay, so 24 reactors we will be getting because of this nuclear cooperation agreements. And there is ENR technology. So we have not got ENR technology yet. This is enrichment and reprocessing. Enrichment and reprocessing. So we know what is enrichment, right? Increasing the percentage of uranium-235 from the naturally occurred uranium, and the reprocessing is nothing but whatever spent fuel is there. Whatever spent fuel is there, for example, the enrichment process that we have discussed, uranium enrichment, uranium-238 is there and uranium-235, and we are increasing the percentage of uranium-235. So whatever will be spent fuel after the increasing the percentage of uranium-235, when you have increased the percentage of uranium-235 and you have utilized it to generate electricity, after that there will be rods in these reactions, right? And these are known as spent fuel rods. So this spent fuel will be deposited on these rods, and you will remove these rods, and you will be carrying out a chemical kind of reaction. You will be putting it in some solution, and you will be taking down these spent fuel, and then you can convert this uranium-238 into plutonium-239. And this plutonium-239 is the base fuel for our nuclear weapon programs. So this is known as enrichment and reprocessing technology, ENR technology basically. But we don't have this technology right now, but we have been promised under nuclear cooperation agreements. But the thing is, every country is pressurizing us to get the membership of Nuclear Supplier Group, NSG. सुना होगा आपने, अभी नहीं सुना होगा तो उसको पढ़ेंगे आगे डिटेल में, ठीक है? सो वी हैव टू बिकम अ पार्ट ऑफ न्यूक्लियर सप्लायर ग्रुप. देयर आर 48 countries, 48 member countries, and the decision is through consensus. What do we mean by consensus? That every party has to be agreed. Decision is not by majority, not by 2/3 majority, simple majority. Decision is by consensus. Everyone has to be agreed, and that is China is there. So China is blocking our membership to get into NSG, and China can influence many countries, right? Because of its trade and manufacturing policy. So we have not got the membership of NSG. In 2008 we were about to get the membership, but ultimately it didn't materialize. So we are not a part of NSG, and China is a big hurdle for us. See, the thing is, there are 5 nuclear weapon states. 5 nuclear weapon states. You might have studied United Nations. United Nations, there are 6 organs: United Nations General Assembly, Security Council, Trusteeship Council, Secretariat, and then the International Court of Justice, Economic and Social Council. पढ़ा होगा ना, 6 organ है United Nations के. And there is a United Nations Security Council, in which you have 5 permanent members and 10 non-permanent members, right? 5 permanent members. Those 5 permanent members are 5 nuclear weapon states. See the irony. 5 nuclear. These are the members who are permanent, who are having permanent seats in United Nations Security Council, and they are 5 nuclear weapon states. And then they say every other country is non-nuclear weapon state. Every other country is non-nuclear weapon state, and they shall not go for developing nuclear weapons. They shall not go for developing nuclear weapons. So this is the idea. We will study one more thing: NPT, Nuclear Non-Proliferation Treaty. Non-Proliferation Treaty means you cannot go for, if you have signed NPT, if you have signed Nuclear Non-Proliferation Treaty, then you cannot go for nuclear arsenal. You cannot go for weaponization programs. You cannot go for nuclear weapon programs in your country. India has not signed NPT. Okay? India has no Prime Minister in India till now, be it Vajpayee ji or Manmohan Singh ji or the current PM Mr. Modi. No Prime Minister has said even once that we are willing to sign or we will sign NPT. But it is a hurdle, because if you want to get a membership of NSG, you have to sign NPT. If you are a non-nuclear weapon state, there are 5 nuclear weapon states, right? And you know the names, right? US foremost, then Russia, China, UK, and France. ठीक है ना? So these are 5 nuclear weapon states. And now there are non-nuclear weapon states, but they are having some nuclear weapon programs, like India, Pakistan. Yesterday it was in news, right? India, Pakistan, and then we have North Korea. We have Iran. Iran earlier signed NPT, but they tried to pursue nuclear weapon programs that we will study in detail. Iran nuclear cooperation agreements and all. And one more country is there, Israel. Okay. Israel has never said officially that it is having nuclear weapons or it is having a nuclear weapon program, but it can be concluded, because there are ample amount of if we cannot say evidence, but there are ample amount of assumptions that there is a nuclear weapon program in Israel. So these are some countries. But see what happens when we talk about getting membership in NSG. When India talks about getting membership of NSG, China promotes Pakistan with it. Okay, so why we shall include only India? We shall include Pakistan also. So that's quite unfair. We don't want to see together with Pakistan. So we are trying hard to get membership of NSG. Let's see when it can be materialized. So ठीक है, कुछ आ रहा है ना समझ में? 5 न्यूक्लियर वेपन स्टेट्स हैं, कुछ नॉन न्यूक्लियर वेपन स्टेट्स. ठीक है, तो ये समझ में आ गया आपको. न्यूक्लियर फ्यूल समझ में आ गया कि हमारे पास फ्यूल नहीं है. सो वी विल बी गेटिंग फ्यूल फ्रॉम दीज कंट्रीज फ्रॉम विच वी आर साइनिंग द एग्रीमेंट्स. न्यूक्लियर रिएक्टर्स, आई टोल्ड यू देयर आर 24 रिएक्टर्स. अभी तक एक भी नहीं आया है. ठीक है, ये फिर एनरिचमेंट एंड रीप्रोसेसिंग टेक्नोलॉजी दैट वी हैव स्टडीड इट, वी कैन नॉट गेट इट till the membership of NSG. So NSG की membership लेना अभी हमारे लिए ज़रूरी है. तो ये चीज़ें हमें मिल रही हैं. क्यों मिल रही हैं? फिर हमें भी कुछ करना होगा ना, तो हमें देखिए क्या क्या करना है. We have to go for separation plan, safeguard agreement and additional protocol. ये क्या है समझ लेते हैं पहले. See, when US announced in 2005, more precisely July 2005, the President of the United States, George W. Bush, and the Prime Minister of India, Mr. Manmohan Singh, former Prime Minister, there was a joint statement regarding this that US will share nuclear technology with India. Now US will share nuclear technology with India. That means we have to sign NPT, because there is a domestic law in United States, US Atomic Energy Act, US Atomic Energy Act 1954. There is a domestic law in United States, US Atomic Energy Act 1954. US वो मैंने लिख दिया है क्योंकि US का law है, ठीक है, US उसमें नहीं. So there is a section in this law that if President of the United States is satisfied and the country has signed NPT, and President of the United States is satisfied. So there are two things. President of the United States has to be satisfied and we must have signed NPT, right? We must have signed NPT. Then US can share nuclear technology with any country. So if a country has signed NPT and President of the United States is satisfied, then the country will be getting nuclear technology from US. But we have not signed NPT. So there is a body, IAEA, International Atomic Energy Agency. It is a specialized agency of United Nations. So it is a kind of watchdog, it is a kind of observer. It goes into the country, investigates, right? So it is a kind of watchdog agency, and it prohibits the country from accumulating the nuclear weapon program, so nuclear arsenals. So they will prohibit the countries. Which countries? Non-nuclear weapon states. If you have signed NPT, and you are a non-nuclear weapon state, then you cannot go for nuclear weapon programs. This is the idea behind it. So this was the issue with Iran. Iran was signatory of NPT, so it was a non-nuclear weapon state. It shall not acquire nuclear weapons with respect to the provisions of NPT, but it was pursuing some nuclear weapon programs. So the IAEA came to know that. They went there and they go for massive investigation, and then they unearthed the program of nuclear weapons in Iran. So this was the idea. So there is a specialized agency, IAEA, International Atomic Energy Agency. This is a specialized agency of United Nations, and it is a kind of watchdog organization. So IAEA raised the question that how US can share nuclear technology with India, because India is not a signatory of NPT and India is carrying out nuclear weapon programs. We are having nuclear weapon programs. So we conducted tests 1974 and 1998, right? So we will discuss when we will come to our nuclear weapon programs. So what IAEA said? IAEA said that India shall go for separation plan. What do you mean by separation plan? You separate your nuclear reactors or your nuclear sites on the basis of its use. Either it is civil or it is military. So you bifurcate them, you segregate them, and IAEA will be investigating your civil reactors or civil sites. IAEA will have nothing to do with military sites. So can you imagine the benefit of this? Officially they are recognizing India as nuclear weapon state. India is having nuclear weapon programs, India is having nuclear civil programs, and IAEA will investigate nuclear civil programs, because we will be getting fuel for this from outside world, right? We are getting fuel from because of this nuclear nuclear cooperation agreement. So we will be getting nuclear fuel. We will be getting nuclear fuel for these reactors. So we cannot use the reprocessed fuel in these reactors. That will be safeguarded by IAEA. So this is clear that what is safeguard agreement. Separation plan, we came to know this is the separation plan at the time of 2006 when these things were happening, because nuclear cooperation agreement Indo-US deal is was announced in 2005. So in 2006 there were 22 reactors and 14 were civil and 8 was in military category. Okay. So this is the separation plan. And what is the safeguard agreement? That IAEA will conduct investigation or any investigation IAEA wants, they can go for investigation in civil reactors or civil sites, but they cannot go for military reactors, right? So this was the safeguard agreement. Then what is additional protocol? What happened in 1990s? In 1990s, Iraq, Iran, North Korea, these countries, these are non-nuclear weapon states, right? But they were pursuing nuclear weapon programs. So they were developing some kind of nuclear weapons. So it cannot be done under the provisions of NPT. So IAEA said that there is some weaknesses in safeguard agreement. There are some weaknesses in safeguard agreement, and the weakness is what? That IAEA is allowed only to investigate the civil nuclear sites. Only civil nuclear sites. So the thing is, countries are hiding its nuclear weapon programs, because IAEA can visit only civil nuclear sites, and they cannot visit anywhere else in the country. So what IAEA said, that there will be some additional protocol under which IAEA can visit any part of the country to investigate whether there is nuclear proliferation is going on or not. What do you mean by nuclear proliferation? That is, you are developing some kind of nuclear weapons. You are sharing technology for nuclear weapons, not for civil use. So this is the thing, additional protocol. So India made IAEA to sign a different additional protocol, because in additional protocol we cannot allow IAEA to go and visit and investigate our military sites, right? So India signed a different additional protocol, not the original one, because original additional protocol says that IAEA will be having the right to visit any site in the country. So India has not signed an original additional protocol, but India has signed some kind of new additional protocol. It negotiated with IAEA, and we have signed a different additional protocol in which we have not allowed IAEA to carry out any investigation in our military sites. Fine. Then self-imposed moratorium on nuclear testing. Self-imposed moratorium is very much similar to the thing like you go home after the class and you say that okay, now I will revise everything whatever has been taught in the class. I will practice previous year questions. I will be reading complete spectrum in 7 days. These are self-imposed moratorium. I will not watch any movie, any web series, any reel on Instagram. These are self-imposed moratorium. You know what is the reality of self-imposed moratorium, right? So, but you have to practice self-imposed moratorium because that will be the discipline and that will help you to pursue your goal. So, self-imposed moratorium means we said that we will not conduct any nuclear test. We said it, right? Then a Nuclear Liability Act, this is the India's obligation. We have to pass a Nuclear Liability Act, and we have passed this in 2010. We have Nuclear Liability Act 2010 to define the liability in case of nuclear accident. If there is an accident like 2011 Fukushima, so if there is a nuclear accident, and we are hearing the news, till now we have not got the confirmation, like some nuclear sites in Pakistan has got some kind of accident, but it has not been confirmed yet. So let's see, in 2-3 days we will be able to know. So in case of nuclear accident, because nuclear accident means it will have a huge impact and long-term impact on the sites, on the area surrounding the site, right? It may have impact on the whole country, because Bhopal gas tragedy was just a gas. It is a nuclear technology, it is a nuclear reactor, nuclear fuel. So if in case of any nuclear accident, you shall fix liability on someone, like you will have to fix liability on operator, the country which is operating. Like in India we have Bhavini and we have NPCIL. We will study these things when we will study nuclear programs. There are basically two operators in India, NPCIL, Nuclear Power Corporation of India Limited, and there is Bhavini. So these two operators are there. So on whom you will fix the liability, whether government of India will be liable, or the operators will be liable, or the supplier of nuclear reactors will be liable. So US wanted that we shall exempt suppliers from nuclear liability. So in case of any accident, the supplier cannot be sued. So you cannot ask compensation from supplier. This was the idea of US. But in India, when we will study Nuclear Liability Act, we will study that if investigation finds that there was a faulty reactor and there was a faulty system there, so we can sue the manufacturer also, the supplier also. So this was the point of contention between US and India, because US wanted complete exemption of any nuclear liability in case of any accident. But we have our own laws, right? So there was the obligation of passing Nuclear Liability Act on India. So this was the basic framework. So if we are signing any nuclear cooperation agreement, we will be getting nuclear fuel, we will be getting nuclear reactor, we will be getting enrichment and reprocessing technology, and what will be our obligation, that we will have to separate our plants. So there will be a separation plan. We have to separate our civil plants and nuclear plants or weapon plants, and then there will be a safeguard agreement in which IAEA will have the right to visit any civil site. But when it came to additional protocol, I told you India signed its own additional protocol with IAEA, and that additional protocol says if India exports uranium to any non-nuclear weapon state, then it will inform to IAEA. Come on, India cannot export uranium. We don't have uranium. We are signing these nuclear cooperation agreements. Thank you. So we don't have uranium for ourselves, from where we will export uranium to any non-nuclear weapon state. So this was one element in that. And if India exports thorium to any non-nuclear weapon states, then again it will inform IAEA. Now there is no technology in which by which thorium can be converted into uranium. There is no technology. So we will inform IAEA, right? And self-imposed moratorium. Self-imposed moratorium, that we will not go for nuclear testing, right? So these are the things. You can write whatever you want to write and then we can proceed to our next topic. ठीक है, तो जो भी स्लाइड्स हैं मैं एक बार दिखा देता हूँ आपको, कुछ इसमें से लिखना है आपको तो लिख सकते हैं। कुछ तो मैंने कैंसिल कर दिया है ना, अब जो है वो आप इसमें से लिख सकते हैं, थोड़ा जो भी लिखना हो आपको। मैं थोड़ा सा रिवाइज करा देता हूँ जो अभी तक हमने जितना देखा है ना, कुछ डाउट है तो फिर पूछ लेना, उसके बाद कंटिन्यू करेंगे इसको। So we started with isotopes. There are 3 isotopes of hydrogen, protium, deuterium and tritium. Protium 1H1, 1H2 and 1H3. उसको हम ऐसे भी लिख सकते हैं 1P1, 1D2, 1T3, ठीक है। The protium forms when it reacts with oxygen, it forms light water. Deuterium forms heavy water, and tritium does not react with oxygen. It is a radioactive element. Then we studied 3 isotopes of uranium: uranium 233, 35 and 38. Uranium 233 and 35 are fissile in nature, whereas uranium 238 is fertile in nature. Uranium 235 and 238 are found in nature in terms of in the form of a mixture, ठीक है। तो जिसमें यूरेनियम 235 जो है वो 0.7% होता है, और यूरेनियम 238 इज हैविंग परसेंटेज ऑफ 99.3%, ठीक है, 99.3%। तो ये आपका यूरेनियम नेचुरली अकर्ड यूरेनियम है। नाउ वी हैव टू यूज यूरेनियम 235 बिकॉज इट इज फिसाइल इन नेचर, सो इंक्रीजिंग द कंसंट्रेशन और इंक्रीजिंग द परसेंटेज ऑफ यूरेनियम 235 इज नोन एज यूरेनियम एनरिचमेंट। ऑन द बेसिस ऑफ द परसेंटेज इंक्रीज्ड देयर आर 2 टाइप्स ऑफ यूरेनियम, राइट, यूरेनियम एनरिचमेंट, लो एनरिच्ड यूरेनियम एंड हाई एनरिच्ड यूरेनियम। अप टू 20% ऑफ there is a nuclear reactor in Tarapur, Maharashtra. It uses only 2.5 to 3.5% nuclear enriched uranium as a fuel. So 2.5 to 3.5% is more than enough to generate electricity. So uranium 235 only 2.5 to 3.5% enriched uranium. Now you can imagine how much enrichment is required for electricity. 2.5 to 3.5% enriched uranium is being used in Tarapur, Maharashtra. So, and there is a submarine of India, INS Arihant. It uses 40% enriched uranium as fuel. So 40% enriched uranium क्या होता है उससे, वो submarine you have to deploy it for longer duration. So if it is using nuclear fuel or there is a nuclear reactor in it, it is using nuclear fuel. So it needs refueling after 13 years, 15 years, 20 years. So you can deploy, because it will be deployed in some strategic locations. So you don't want anybody to know where you have deployed your submarines. So using nuclear fuel is very much useful in these cases. So INS Arihant is there. It uses 40% enriched uranium as its fuel. सब चीज़ें पढ़ेंगे जब न्यूक्लियर वेपन प्रोग्राम पढ़ेंगे, सारा चीज़ अभी मैंने ऐसे ही बता दिया है, वो आ गया था, ठीक है। सो this is uranium enrichment. Up to 20% low enriched uranium, civil use. More than 20% high enriched uranium. More than 90% weapon grade uranium, ठीक है। Then we saw the nuclear cooperation agreement. Why we have to go for nuclear cooperation agreement? Because we don't have fuel, we don't have technology also. ऐसा नहीं है कि 2005 से पहले इंडिया में कोई न्यूक्लियर रिएक्टर नहीं था, ठीक है। वो पढ़े ना अभी हमने, 22 reactors were there, right? And we have conducted nuclear tests also. So we conducted 1974 test, we conducted 1998 test. Means we have nuclear reactors which are indigenous, more or less. We got some cooperation from Canada, we got some cooperation from US also, but now more or less it is indigenous. We are using plutonium. We have fast breeder reactors. When we will discuss all nuclear weapon programs, we will discuss everything, ठीक है। तो we have nuclear reactors of our own, but we are developing nuclear weapons from it, because we will be getting nuclear cooperation for civil use from outside the world, from outside countries, right? तो हम अपने न्यूक्लियर फ्यूल का, अपने रिएक्टर का हम वेपन बना लेते हैं, बाकी इलेक्ट्रिसिटी के लिए मिल जाएगा, ठीक है। तो ये, और फिर उसके बाद हमने पढ़ा ये क्यों ज़रूरी है, फिर इसमें हमने पढ़ा क्या क्या मिलेगा हमें, ठीक है। एक न्यूक्लियर फ्यूल मिलेगा क्योंकि हमारे पास तो लेस देन 2% है वर्ल्ड का, और हमारी नीड ज़्यादा है क्योंकि हम ज़्यादा हैं, ठीक है। फिर उसके बाद न्यूक्लियर, हिंदी में मैं नहीं पढ़ा पाता इसलिए, न्यूक्लियर रिएक्टर से फिर तो हमने देखा 24 रिएक्टर्स मिलेंगे हमको, ठीक है। 12 रिएक्टर रशिया से मिलेंगे, 6 फ्रांस से, 6 यूएस से। ये ना टेक्नोलॉजी देखी हमने, अभी तक हमें मिली नहीं है क्योंकि हमें एनएसजी की मेंबरशिप नहीं मिली है। एनएसजी 48 मेंबर्स हैं वहाँ पर, चाइना है, चाइना ने और कुछ 8-9 कंट्रीज़ को इन्फ्लुएंस कर रखा है, तो वो 8-9 कंट्रीज़ मिल के चाइना, 10 कंट्रीज़ लगभग मिलके प्रेशर बनाते हैं कि नहीं मिलेगी आपको टेक्नोलॉजी, ठीक है, आपको मेंबरशिप नहीं मिलेगी। चाइना, इंडिया को देना है तो ठीक है, पहले पाकिस्तान को भी दो। तो पाकिस्तान का रिकॉर्ड इस बारे में काफ़ी ठीक है अच्छा है कि वो न्यूक्लियर प्रोलिफरेशन, AQ खान, ये सब बहुत केसेस हैं पाकिस्तान के, इन्होंने पास ऑन की। काफ़ी न्यूक्लियर प्रोलिफरेशन में बहुत नाम है पाकिस्तान का कि इन्होंने न्यूक्लियर वेपन टेक्नोलॉजी पास ऑन की है और इनको मिली भी है ना, ये सब है। तो अब रिकॉर्ड अच्छा नहीं है NSG की मेंबरशिप, बहुत दूर की बात है, ठीक है। फिर इंडियाज़ ऑब्लिगेशन क्या था, तो एक हमारा सेपरेशन प्लान था, वो हमने देखा, हमने 2006 में सेपरेट कर लिया है। और वो ग्रेजुअल करना था लेकिन हमने अनाउंस कर दिया, क्योंकि हमें तो पता है ना कि कहाँ पर न्यूक्लियर है, कहाँ पर सिविल है, कहाँ पर वेपन प्रोग्राम है, क्या चल रहा है, तो हमने कर लिया। सेफगार्ड एग्रीमेंट मैंने आपको बता दिया, IAEA कैन विजिट इन्वेस्टिगेट। एडिशनल प्रोटोकॉल मैंने आपको बता दिया है ना, वो एक यू कैन लाफ एट एडिशनल प्रोटोकॉल दैट वी हैव साइंड। फिर उसके बाद सेल्फ इम्पोज मोरेटोरियम है, वो मैंने आपको समझा दिया, सेल्फ इम्पोज मोरेटोरियम। न्यूक्लियर लाइबिलिटी एक्ट मैंने आपको बता दिया है, 2010 में हमने पास किया है, और उसके प्रोविजंस अभी हम नहीं पढ़े हैं, अभी हम आगे पढ़ेंगे इसको, ठीक है, बाद में। फिर वेरी इंपॉर्टेंट टॉपिक दैट वी हैव टू स्टडी इज इंडो US न्यूक्लियर डील और 123 एग्रीमेंट। इसका मैंने बेसिक आपको बता दिया था, क्या 2005 में जॉइंट स्टेटमेंट आया था, एंड इट इज़ वन ऑफ द रिमार्केबल अचीवमेंट ऑफ मिस्टर सिंह एज प्राइम मिनिस्टर ऑफ इंडिया। तो ये क्या था, ये डील को थोड़ा सा हम समझने की कोशिश करेंगे, ठीक है ना। इंडो न्यूक्लियर डील, तो मैंने आपको बताया था सेक्शन 123, इसको 123 एग्रीमेंट भी बोलते हैं, ठीक है। इट इज़ कॉल्ड एज 123 एग्रीमेंट ऑल्सो बिकॉज सेक्शन 123 ऑफ दिस एग्रीमेंट, US एटॉमिक एनर्जी एक्ट 1954, इट सेज इफ प्रेसिडेंट ऑफ द यूनाइटेड स्टेट इज सेटिस्फाइड, लिख लेना, लिखने का टाइम मिले, समझ लो, फिर मैं तो देता ही हूँ टाइम लिखने के लिए, देखा आपने, है ना। सो इसमें क्या है कि इफ़ President of the United States POTUS is satisfied and the country has signed NPT, that then United States can share the nuclear technology with that particular country. तो हमने NPT साइन नहीं किया है, ठीक है, हमने NPT साइन नहीं किया है। So US passed a Hyde Act in 2006। अब Hyde Act क्या कहता है, Hyde Act कहता है कि इंडिया को एग्जेम्पशन मिलेगा इस, ये जो प्रोविजन है सेक्शन 123 में, दैट POTUS इज सेटिस्फाइड एंड NPT मस्ट बी साइंड। सो हाइड एक्ट एग्जेम्प्ट इंडिया फ्रॉम दिस रिक्वायरमेंट कि ठीक है, आप NPT नहीं साइन किया है आपने, इफ प्रेसिडेंट ऑफ द यूनाइटेड स्टेट इज सेटिस्फाइड देन न्यूक्लियर टेक्नोलॉजी कैन बी शेयर्ड। अब आपको क्या लग रहा है, US से इतनी अच्छी दोस्ती कैसे हो गई हमारी के न्यूक्लियर टेक्नोलॉजी, दे आर अमेंडिंग देयर डोमेस्टिक लॉ फॉर अस। तो ठीक है, ये एक डिप्लोमेटिक विन ज़रूर है इंडिया की, बट इंडिया इज़ अ ह्यूज मार्केट, है ना, इंडिया इज़ अ ह्यूज मार्केट। वी आर बाइंग 6 न्यूक्लियर रिएक्टर्स फ्रॉम US, तो it is burdening a huge cost on India also, and India needs more and more because this we will be having nothing from this 24 reactors. We will be needing more and more reactors in future because our energy needs are increasing. Need of electricity, we need to, if we need to develop, then we need to have energy, है ना। energy has big role in developing the country। पढ़ा होगा आपने थोड़ा inclusive growth वगैरह, है ना, physical infrastructure और ये सारी चीज़ें। तो इसमें हमें ज़रूरत है, और इससे क्या है कि आपको जो है इंडिया एक ह्यूज मार्केट है, US को मार्केट मिल रहा है, और हमने काफ़ी चीज़ें इनकी मान भी ली है ना, सेपरेशन प्लान एट्सेट्रा एट्सेट्रा, सेल्फ इम्पोज मोरेटोरियम के, ठीक है, हम नहीं करेंगे। और फिर IAEA तो है ही, वो वॉच डॉग है, आप कुछ भी गड़बड़ करते हो तो IAEA है। तो ये डील इस कॉन्टेक्स्ट में साइन हो रही है, ठीक है, ये आपको समझ आ गया कि ये जो 123 एग्रीमेंट है ये इस कॉन्टेक्स्ट में साइन हो रहा है, मतलब इंडिया के लिए एक बड़ी विन है, विन विन सिचुएशन है ना इंडिया के लिए, ठीक है। दिस इज़ द इंडो US न्यूक्लियर डील। अब ये डील में क्या क्या चीज़ें हैं ये हम डिटेल में अब समझने की कोशिश करेंगे। तो पहली चीज़ आपने पढ़ी थी, हमें क्या क्या चाहिए, एक फ्यूल चाहिए, रिएक्टर चाहिए, और ENR टेक्नोलॉजी, ये हमें मिलने वाला था, है ना। तो देखो US जो है, US विल सप्लाई फ्यूल टू इंडिया, एंड इट विल नॉट ओनली सप्लाई फ्यूल टू इंडिया, इट विल ensure fuel reserve for 1 year, ठीक है। तो US will not only supply fuel, it will ensure that we have fuel for 1 ईयर, मीन्स इट विल गिव अस प्रिडिक्टेबिलिटी। ये प्रिडिक्टेबिलिटी मिल जाएगी ना आपको कि आपके पास फ्यूल है, वी आर नॉट रनिंग शॉर्ट ऑफ फ्यूल, है ना। जैसे ही अगर हमारे पास 1 साल का फ्यूल है तो आपको पता है ना 1 साल तक के लिए तो हमारा रिएक्टर चलने वाला है, तो ये एक सर्टेनिटी है, अनसर्टेनिटी नहीं है यहाँ पर कि कब यूएस से रिलेशन ख़राब हो गया तो अचानक फ्यूल आना बंद हो गया, ऐसा नहीं है। एंड इफ़ यूएस विल नॉट बी एबल टू एक्सपोर्ट फ्यूल टू अस देन इट विल अरेंज इट फ्रॉम एनीवेयर एल्स। तो ये इस डील का प्रोविज़न है, ठीक है, कि अगर यूएस ने आपको यूएस को आपको फ्यूल देना है, ये आपका 1, 2, 3 एग्रीमेंट का पार्ट है। इफ़ यूएस इज़ फेल्ड टू अरेंज इट फ्रॉम देमसेल्व्स देन दे विल अरेंज इट फ्रॉम एनीवेयर एल्स। हमें कोई मतलब नहीं है, हमें फ्यूल चाहिए बस, ठीक है। तो ये एक इसका पहला पॉइंट है। दूसरा, न्यूक्लियर रिएक्टर आपको मैंने बता दिया 6 न्यूक्लियर रिएक्टर आने वाले हैं, है ना। जनरल इलेक्ट्रिक है, वेस्टिंग हाउस है, वो वहाँ की कंपनीज़ हैं, तो वो अभी पढ़ेंगे जब न्यूक्लियर लाइबिलिटी एक्ट पढ़ेंगे, क्या इशू चल रहा है न्यूक्लियर लाइबिलिटी एक्ट में, वो अभी देख लेंगे। दूसरा है रीप्रोसेसिंग ऑफ न्यूक्लियर फ्यूल अलाउड बट टू बी सेफगार्डेड विद IAEA। इसका क्या मतलब है कि जो भी अब ये फ्यूल देंगे आपको, रिएक्टर देंगे आपको, अब रीप्रोसेसिंग जब आप करोगे, जब रिएक्टर से स्पेंट फ्यूल आ गया तो इस स्पेंट फ्यूल का आप रीप्रोसेसिंग कर सकते हो और आपको प्लूटोनियम मिल सकता है ना। तो अर्लियर जब ये डील नेगोशिएट हो रही थी, यूएस वाज नॉट अलाउइंग इंडिया टू रीप्रोसेस द फ्यूल, पता है रीज़न आपको क्यों, बट लेटर जब डील यहाँ पे कंक्लूड हो रही थी उस समय वी गॉट द प्रोविजन इन दिस एग्रीमेंट दैट इंडिया विल reprocess the fuel, but it will combine fuel from every site and it will generate a central facility, and that central facility will be safeguarded with IAEA. IAEA can visit there and it can monitor, it can investigate whether the fuel is being proliferated or not, ठीक है। तो ये एक इसमें एग्रीमेंट है। दूसरा, टर्मिनेशन वर्सेस नो टर्मिनेशन। ये जब डील साइन हो रही थी, जब डील बन रही थी, तो उस समय यूएस का एक पॉइंट था कि जैसे ही अगर इंडिया ने न्यूक्लियर टेस्ट कंडक्ट किया ये डील खत्म हो जाएगी, टर्मिनेट, ठीक है, ख़त्म, सब पैक करो, सारा उनको वापस दे दो, उनकी टेक्नोलॉजी ख़त्म, बात ख़त्म, डील ख़त्म। बट जब डील साइन हुई तो उस समय क्या हुआ कि इसको कर दिया, ये वाला क्लॉज ख़त्म कर दिया गया। अब क्लॉज क्या है कि इफ़ इंडिया विल कंडक्ट अ न्यूक्लियर टेस्ट देन यूएस विल ट्राई टू अंडरस्टैंड द सर्कमस्टेंसेस एंड द नेगोशिएशन between the two countries will begin, which will be concluded in 12 months, and ये पूरे क्लॉज में कहीं भी नहीं है कि डील विल बी टर्मिनेटेड। दिस क्लॉज इज नोवेयर mentioned that if India will go for nuclear testing then US will terminate the deal। ये ऐसा क्लॉज कहीं भी नहीं है, ठीक है। ये क्लॉज था पहले, फिर इंडिया ने नेगोशिएट किया है इसको, और अब क्या है कि इफ़ India will conduct a nuclear test then US will try to understand the circumstances and a talk will begin between the two countries and which has to be concluded in 12 months। तो इंडिया के लिए कोई बड़ी बात नहीं है ना, टर्मिनेट, डील तो ख़त्म नहीं हो रही। और एक है कि नोटिस पीरियड, जो कॉर्पोरेट में आपने देखा होगा कि अगर किसी को भी डील ख़त्म करना है तो 1 साल का नोटिस पीरियड देना होगा कि ठीक है ये डील 1 साल बाद ख़त्म हो जाएगी अब न्यूक्लियर डील। और ये वैसे भी ये जो इंडो यूएस न्यूक्लियर डील है इट इज़ रिव्यूड एनुअली बाय प्रेसिडेंट ऑफ द यूनाइटेड स्टेट्स। तो हर साल जो है उसको रिन्यू किया जाता है, ठीक है, रिव्यू किया जाता है। तो वही समझ रहे हो ना, रिव्यू कर रहे हैं मतलब वो 1 साल के लिए बढ़ जाता है। फिर अगर किसी भी कंट्री को ये डील ख़त्म करनी है देन दे हैव टू गिव 1 ईयर एडवांस नोटिस। तो इससे भी क्या सर्टेनिटी बनी हुई है ना, एक प्रिडिक्टेबिलिटी है कि आपके पास इतना फ्यूल इंश्योर्ड है, ये डील आपको पता है कि इसके जो भी प्रोविजंस हैं ये 1 साल तक तो चलने वाले हैं, है ना, इस तरह से। अब सिग्निफिकेंस क्या है इस डील का, सिग्निफिकेंस क्या है इस डील से, हमने क्या अचीव किया। एक तो हमने अचीव किया अपना न्यूक्लियर आइसोलेशन, क्योंकि हम न्यूक्लियर नॉन वेपन स्टेट कैटेगरी में हैं तो हमें कोई भी टेक्नोलॉजी देगा नहीं, क्योंकि टेक्नोलॉजी किसको ट्रांसफ़र की जा सकती है, जो एनपीटी के मेंबर है, the countries who are member of NPT, so they will be getting nuclear technology from nuclear weapon states। ये NPT का प्रोविज़न है। We are not a signatory of NPT। क्यों नहीं है हम signatory of NPT, आपको पता है, we are pursuing our nuclear weapon programs, है ना। ऐसा नहीं है कि हमें बस किसी को मारना है इसलिए हम nuclear weapon program, और इसलिए तो बिल्कुल नहीं कि पाकिस्तान के पास है इसलिए हमारे पास। हमने 74 में टेस्ट कंडक्ट किया है, पाकिस्तान ने 99 में किया है, तो वो सेम पेडिस्टल पे, तो ये तो हमारी बेइज्जती है ना, सेम पेडिस्टल पे रखेंगे अपने आप को पाकिस्तान के साथ। चाइना, जो हमारा मेन कंसर्न है वो चाइना है, ठीक है। और हमारी नो फर्स्ट यूज़ पॉलिसी है, अभी हम इसको पढ़ेंगे, नो फर्स्ट यूज़ डॉक्ट्रिन। हमारा जो न्यूक्लियर यूज़ का है, हमारा ये है कि नो फर्स्ट यूज़, हम फर्स्ट यूज़ नहीं करेंगे अपना न्यूक्लियर वेपन, ठीक है। पाकिस्तान की नहीं है ऐसी पॉलिसी, तो हमें फिर थोड़ा क्या कभी बनाना पड़ता है ना। तो ये हो गया ये सिग्निफिकेंस एक तो समझ में आ गया आपको कि हमारा न्यूक्लियर आइसोलेशन इससे ख़त्म हो गया है। वी विल बी गेटिंग टेक्नोलॉजी फ्रॉम डेवलप्ड नेशन, वी विल बी गेटिंग न्यूक्लियर रिएक्टर्स, वी विल बी गेटिंग न्यूक्लियर फ्यूल, वी विल बी गेटिंग टेक्नोलॉजी ऑल्सो, एनरिचमेंट एंड रीप्रोसेसिंग, ठीक है। फिर इसमें ये हमारे लिए एक मॉडल एक्ट भी बन गया है, 1, 2, 3 एग्रीमेंट जो इंडिया का साइन हुआ है। Now we can sign deal with other countries, like we can sign deal with Japan, we have signed it. We can sign deal with France, we can sign deal with Russia on same lines. You have seen we have promised very little and we have got a lot in this deal, 1, 2, 3 agreement, nuclear cooperation agreement that we have discussed. So we have promised very little, no first use, more self-imposed moratorium. So these are not the big things that we have to promise, right? And we got a lot, we will be getting, because अभी तक तो ये सारी चीज़ें मटेरियलाइज नहीं हुई है, बट वी विल बी गेटिंग न्यूक्लियर फ्यूल ऑल्सो, वी विल बी गेटिंग न्यूक्लियर रिएक्टर्स ऑल्सो, सो वी विल बी गेटिंग अ लॉट ऑफ थिंग आउट ऑफ दीज एग्रीमेंट्स, ठीक है। तो इसके आगे फिर हम नेक्स्ट क्लास में कंटिन्यू करेंगे, है ना। आपको कुछ डाउट है अभी जितना हमने पढ़ा तो उसमें से आप पूछ सकते हैं। रिप्रोसेसिंग यही है, जो एनरिचमेंट आपने देखा है, एनरिचमेंट में क्या होता है, वी आर इंक्रीजिंग द कंसंट्रेशन ऑफ इंक्रीजिंग द परसेंटेज ऑफ यूरेनियम 235। फिर उसके बाद हम क्या करते हैं कि वो जो रिएक्शन कैरी आउट होता है उसमें रॉड्स हैं, तो यहाँ पर ये जो रॉड्स हैं, ये रिएक्शन सपोज कैरी आउट हो रही है, ठीक है। ये इलस्ट्रेटिव डायग्राम है, ऐसा कुछ होता नहीं है बहुत, ये समझने के लिए हम समझ रहे हैं, ठीक है, क्योंकि वो समझ रहे हो ना। तो ये यहाँ पर ये डिपॉजिट्स हो गए हैं, ठीक है, जो आपका स्पेंट फ्यूल है। इसको हमने क्या किया, बाद में एक केमिकल रिएक्शन करवाया, एक सॉल्यूशन रखा यहाँ पर, ये एक केमिकल सॉल्यूशन है, और ये रॉड को यहाँ पर लाकर इमर्स कर दिया। तो फिर यहाँ से क्या हुआ, ये जितना भी स्पेंट फ्यूल था, यूरेनियम 235 जो है वो आपका यूटिलाइज हो गया है, और जो यूरेनियम 238 है वो यहाँ पर आकर डिज़ोल्व हो गया है। इसको आप प्लूटोनियम में कन्वर्ट कर सकते हैं, ठीक है। और कुछ आपको कुछ समझ में आया थोड़ा बहुत, ठीक है, पूरा आ गया, चलो बढ़िया बढ़िया। इसको क्या करना है कि अभी नेक्स्ट क्लास जब हमारी होगी तो मैं इसका PDF शेयर कर दूंगा, एक नोट्स बना के, है ना, जितना भी हमने डिस्कस किया है उसको आपको पढ़ लेना है, वो आपकी नोट्स। हाँ हाँ ठीक है, ठीक है, देखते हैं वो क्या ठीक है, ठीक है। तो ये और कुछ डाउट नहीं है ना। चलो, थैंक यू वेरी मच, थैंक्स अ लॉट।